So these are the two derivative formulas that you've just written into your notes, and we have two more to go. So we've learned how to find the derivatives of exponential functions. The only one left is to find derivatives of logarithmic functions. So you can follow this derivation if it's interesting to you. If I want to find the derivative of y equals natural log of x, I could use implicit differentiation. You can e both sides, so make both sides the exponent on e. I would get e to the y equals x. And now I can take the derivative. I'll have to use the chain rule and implicit differentiation. So the derivative with respect to x of e to the y is e to the y times dy dx. And the derivative with respect to x of x is just 1. Now if I try to isolate the dy dx, I have to divide both sides by e to the y, and I get 1 over e to the y. But what is e to the y? E to the y equals x. So the derivative with respect to x of the natural log of x is 1 over x. If we incorporate the chain rule, the derivative with respect to x of the natural log of u is 1 over u times du dx. Get that one in your notes, and we'll do an example. So if I'm looking for the slope of the tangent line to y equals the natural log of x squared at the exact point where x equals e squared. Remember, anytime I want to find the slope of a tangent line, first I have to find a formula for slope everywhere. Then I can plug in the x value I care about. So I'm going to start by finding dy dx. In this case, I have a function y equals the natural log of u, and u equals x squared. So dy dx will be 1 over u times du dx. I get 1 over x squared times 2x. And then notice how far down that simplifies. My derivative, dy dx, simplifies to 2 over x. So again, you're not required to simplify on the free response section, but this is common for logarithmic functions when we take a derivative, that a lot of stuff is going to cancel out. So just keep an eye out for it, especially when you're taking the multiple choice section. Now that I know a formula for the derivative anywhere, I'm going to plug in the x that I care about. So dy dx evaluated at x equals e squared is 2 over x, so 2 over e squared. I think you'll find that's answer choice B. So one more derivative formula. What if I need the derivative of a logarithmic function, but it's not a natural logarithmic function, it's a logarithmic function with a different base. So you'll note, similar to the exponential function, the derivative formulas are similar. If I want the derivative with respect to x of log base a of x, it's just 1 over x times the natural log of a. So that natural log of a is in the denominator with the x. With the chain rule, the derivative of log base a of u is 1 over u times the natural log of a, again, times du dx. So one more example. What if I need the derivative of log base 5 of square root of x? Well, a is standing for 5 is standing in for a, and the square root of x is standing in for u. I'll use the formula you just wrote down. Dy dx is going to equal 1 over u times the natural log of a, all times du dx. So I've got 1 over the square root of x, that's 1 over u, times the natural log of 5, that's the natural log of a that's still supposed to be in the denominator, times the derivative of square root of x is 1/2 x to the negative 1/2. If you're taking the free response section, feel free to leave it like that. But notice again, when we take derivatives of logarithmic functions, a lot of stuff ends up canceling out. So you just might like to watch how the rest of this works, how we can simplify this expression. You'll need to know that 1 over 2 times x to the negative 1/2, that's just 1/2 of 1 over x squared. So you can see in the second to last line I've replaced 1/2 x to the negative 1/2 with 1 over 2 square root of x. The square root of x and the 2 square root of x in the denominators multiply together to become 2 times x. So final answer, 1 over 2x natural log of 5.